Hello, my name is Michele Albach, and I'm here to tell you about our work titled The Role of Accuracy in Algorithmic Process Fairness Across Multiple Domains. Our work has to do with algorithmic decision makers, or ADMs for short, meaning any machine learning program that uses input data to make predictions or decisions, often about people. ADMs are increasingly used to aid or even replace human decision makers in potentially life-changing consequences. For example, an ADM could be used by a judge to help decide whether or not to grant bail to a defendant. Because of the consequences that these decisions can have, it is important to ensure that they are made fairly, although the exact definition of the word fairness is not always clear. We focus on a specific type of fairness called process fairness, which has to do with ensuring that the processes involved in ADMs are considered fair as opposed to the outcomes. Specifically, this means that we are looking at pieces of information or features that are used about a person to make a decision about them, and whether or not those features are perceived as fair. So, for example, in the bail domain, one of those features could be criminal history, and we would be concerned with whether or not people think it's fair to use criminal history in bail domain decisions. A mathematical definition of process fairness as it relates to ADMs was proposed by Kalaka et al. 2016, which depends on the proportions of people who think that a given feature is fair to be used by algorithmic decision makers. And they do this using empirical data where they actually survey people and count the number of people who think that it's fair versus it's unfair. Doing this, they determine that process fairness can be achieved, but that a loss of accuracy is unavoidable. And this relates to the commonly referenced unavoidable accuracy fairness trade-off in the literature. A problem with this technique, actually, though, is that it somewhat relies on the assumption that there's going to be a certain level of consensus able to be reached as to whether or not a specific feature is fair or unfair to be used. Whereas actually in their later work, Kalaka et al. 2018, which I'll abbreviate to GH18, show that in the bail domain, actually very low levels of consensus are reached by their survey respondents as to which features are fair or unfair to be used by ADMs. However, in the same work, they also show that fairness judgments can be well predicted using their respondents' opinions about 8 properties that they propose to describe the features. So 2 of those, for example, are whether or not the feature is relevant to the decision being made and whether or not the feature is a reliable source of information. So then they use logistic regression and they are able to take answers to the questions about those properties to then predict how fair people think that it's going to be to use those features by an ADM. This is a really cool result because it implies that there is a shared moral reasoning connecting the properties to the perceived fairness of the features. If this slide didn't make much sense, that's okay because we're going to talk about it a lot more in detail later, since this work was an inspiration for our work, which I'll overview briefly now. We also take a descriptive process-based approach using empirical data, specifically by surveying Amazon Mechanical Turk workers. We build on the work done by GH18 using their same 8 properties. We replicate their results in the bail domain, but also generalize to 5 new domains so that we have 6 total domains to compare between. We find that we are able to well predict the differences in fairness judgments using the property assignments, just like GH18, but in all 6 domains we can do this. And furthermore, we're able to do it between domains as well when we are training in one domain and testing in another domain and still perform well. Finally, we find that the property relevance, which behaves similarly to our newly proposed property increases accuracy, holds the majority of the predictive power, although our demographic analyses reveal that there are important differences in some specific domains. So now let's go into all of this in more detail, starting with the exact survey questions that we used, which were inspired by GH18 and were in fact identical in the bail domain. So there's 2 main types of survey questions. There are the fairness judgment questions, which have to do with determining whether or not a feature is considered fair to be used in the domain and answered on a Likert scale. So an example of this question could be, how fair is it to determine an applicant's eligibility for a loan using information about their marital and family status? So in this case, the feature that we are considering is marital and family status, and the domain is loan decisions. The second type of question are property assignment questions. And this is where there's actually going to be 8 different questions per feature for each of the 8 different properties. And these ones are more statements, but they are still answered on a Likert scale. So one example is information about their marital and family status is relevant to loan decisions. So in this case, now the property that we are considering is relevance, and there would be different versions of this statement for each of the other 7 properties as well. The graphic on the left here is kind of a sneak peek of what we did with the answers to these questions, which is identical to what GH18 did in their work as well, that using logistic regression, we are able to, per feature, take the answers to the 8 different property assignment questions and use that to predict whether that feature was perceived as fair or unfair to be used in, for example, loan decisions. Lastly, we also asked demographic questions of all of our survey respondents for demographic analyses later on. So these are our actual results. These are the accuracy levels that we are able to achieve by our models using logistic regression. We do so by performing 1,000 50-50 train test splits within each domain, as well as over all domains pooled together. I'll draw your attention specifically to, in the very bottom left there, that 82% is the average that we are able, or the accuracy level that we are able to achieve when pooling all domains together. And so even when all domains are pooled together, we are still able to well predict fairness judgments. And furthermore, that value is even higher than if you average the individual within domain accuracy levels that we achieve all those values above it. So this result, taken with the fact that we are also able to achieve similarly high levels of accuracy in our cross-domain tests where we train in one domain and then test in a different domain, suggests that the properties hold similar relative importances across domains and that our respondents used similar moral reasonings when making fairness decisions across the domains. So it didn't matter what domain it was that our respondents were thinking about, their relative, the way that they thought about it from the properties to the fairness judgments was the same anyways, which is cool. So then now that we know that we are able to well predict fairness judgments, we wanted to take a deeper dive into the relative predictive powers of each of the properties. And we do this in 2 ways. First, we observe the weightings associated with the properties. So we do this by calculating which properties have weights that are significantly different from 0 and have a significant effect on fairness judgments. And second, we train new predictors using subsets of the 8 properties, including new models that are trained on only a single property to predict fairness judgments, and then we compare the levels of accuracy amongst these. So using this first method, we find that other than causes outcome in the bail and the hospital domain, relevance is actually the only property that has a consistently significant effect on fairness judgments in all 6 domains. So basically, this is telling us that the majority of the predictive power is coming from relevance, and relevance is basically just able to predict fairness judgments mostly on its own. And that result is further validated by our second method here, where we train new models using subsets of the properties. So this is for each 6 of the properties of the domains individually, as well as all domains pooled together. So that leftmost square that you see is the same value, the 82% that I showed you in the table earlier. And then the one next to it, one to the right, is the accuracy level that we're able to achieve when training on just relevance alone. So the model that is only learning from the property relevance is able to perform basically just as well as all 8 properties together. And furthermore, then one more to the right, that is the accuracy that we achieve when we're training on all 7 properties minus relevance. So as soon as you take relevance out of the picture, you get a major jump down in accuracy levels. And furthermore, this is also true in GH18's original data in the bail domain specifically, which you can see by the red stars. So basically, we've found that relevance is holding the fort down all by itself, and relevance is the one that mostly is able to predict these fairness judgments very well by itself. So we wanted to figure out why that is, and we are thinking about how our respondents had interpreted the word relevance, and we come up with 2 possible different interpretations that they could have made, because maybe relevance is just a little bit too vague of a term and we're not sure how they were thinking about it. First of all, maybe a feature was labeled as relevant to the decision if it was considered fair to be used in decision making. So we were worried that maybe relevance was just interpreted as kind of a synonym for fairness, so then obviously it was able to well predict fairness. Our second prediction, though, was that a feature was labeled as relevant to the decision if it would increase decision accuracy. So this is where now we get our newly proposed property that we think is a more specific property that we call increases accuracy. And so to check for this, we do 2 additional surveys. The first where we remove relevance entirely as a property without replacing it with anything new. The reason why we do this is because we were worried that if relevance had been interpreted as a synonym for fairness, then maybe it would have distracted from the other properties and taken away from their predictive power. And then second, we replace relevance with our new, more specific property, increases accuracy. And an example of what the survey question would look like now is here, using information about their marital and family status would increase the accuracy of loan decisions. So let's look at the results of these two new surveys. First of all, here the one on top is what we've already seen to compare, and the one on bottom is the new result. And the main takeaway is that our new property increases accuracy does seem to follow the same qualitative pattern as relevance. There are some other weights that are now significant that weren't before, and causes outcome in particular is significant in more domains, but it is still true that increases accuracy now instead of relevance is the only property that has a consistently significant effect on fairness judgments. And then the fact that it's following the same pattern is further seen here in our second analysis method, that now we're looking at the orange triangles represent the accuracy levels achieved in the survey where relevance was replaced with increases accuracy. So you'll see that those accuracy levels do jump down a bit, which is possibly due to some of our initial respondents interpreting relevance as more of a synonym for fairness than a synonym for increases accuracy. But we do still see the same pattern that second column, where now that's the model that is using only increases accuracy as a single property, is able to perform just as well, or in some domains even better, as all 8 properties combined. The other takeaway from here is that in that third column where you're looking at our other new survey, you'll see that the green circle, which is the accuracy level achieved in our survey where we just totally removed relevance as an option, is about the same. And it doesn't necessarily perform that much better than our original results ignoring relevance, which tells us that relevance hadn't acted as too much of a distractor and hadn't taken away from the predictive power of the other properties too much, which is good. So our main takeaway from these results is that our more specific property increases accuracy is the most important property when it comes to predicting fairness judgments in all 6 domains, as well as over all domains pooled together. So finally, it was important to us to perform demographic analyses because a huge limitation in our study is the lack of diversity in our sample. However, due to our large total number of participants, we still were able to mathematically perform these analyses because we had enough from most demographic groups. And we do this in 2 ways. First, we train new logistic regression models with the independent variable now being demographic information instead of property assignments. So this is to check for significant effects from the demographic information about our survey respondents to their fairness judgments. But then we also do this with now the dependent variables as the property assignments to check for significant effects from demographic information to property assignments as well. Second, we also just simply repeat all of our main analyses on data after removing privileged groups. So we do this twice, once on our data without any of our white respondents, and then on our data without any of our male respondents as well. Results from that first method, we find that actually there are very few weights that are significantly different from 0 when predicting fairness judgments using demographic information, as well as when predicting property assignments using demographic information. So what you're seeing on this table here are the only 5 weights out of all of the possible ones that were different from 0 when predicting fairness judgments. So what exactly this means, that first row, for example, since that confidence interval does not include 0 and it is significantly different, then that means that whether or not our respondents identified as Black had a significant effect on their opinion of the fairness of using current charges in the bail domain, and same for the other rows. So despite the fact that there were very few of these significant effects, one interesting thing that we saw was that other than the one row where you see education here, every single significant weight that we found had to do with ethnicity. So despite the fact that there are not very many of them, it is still an important finding that there are some differences resulting from demographic information that have effects on fairness judgments and property assignments. Our second method is that we just simply remove privileged groups from our data and then repeat our analyses to see if we find any differences. So doing so introduces no changes to our early conclusions because the 8 properties are still able to well predict fairness judgments using this data in all cases. However, the differences that we do find are when we look into our deep dive analysis of the relative predictive powers of each of the properties relating to relevance and increases accuracy specifically. So using data without Caucasians in the hospital domain, but only in the hospital domain, this is not true in any other domains, we find that now relevance and increases accuracy no longer have significant effects on fairness judgments. And furthermore, in the survey where relevance was replaced with increases accuracy, now causes outcome seems to be the property that is outperforming the others. So you can see that in the graph here on the left, that It's the fourth column that the triangle, and that is the model using only causes outcome as a predictor for fairness judgments, is now the one that seems to perform better than anything else, and in fact does perform better than all properties combined, rather than being increases accuracy as we'd seen in other analyses. And then, using data without males in the insurance domain, now we find that increases accuracy no longer follows the same qualitative pattern as relevance. So this is the graph on the right here. You see that the triangles are way lower. They're not doing as well. So specifically, without males in the insurance domain, relevance is still an important predictor of fairness judgments, but increases accuracy doesn't stand out to the same point that relevance did before. So these results are a little bit confusing, and in the scope of all of our other conclusions are hard to interpret. They definitely warrant future research, in particular future research with more diverse samples, to see why this possibly is. So lastly, I'm just going to reiterate some of the conclusions that we made. So first of all, we find that GH18's 8 feature properties do indeed describe the moral determinants used for making fairness judgments in all 6 domains, and furthermore that the properties are predictive in similar ways in each domain. So this is cool because it implies that maybe a lot of the research out there that focuses within only a single domain rather than multiple domains can have hope that that would apply to other domains as well, because we find that the people thinking about fairness judgments in each of those domains are thinking about them in similar ways, no matter which domain it is. Then, the property that is best at predicting the perceived fairness of a feature in most cases is whether or not a feature would increase the decision accuracy, or more specifically, whether or not that feature is perceived to increase the decision accuracy by our survey respondents. Lastly, we also find that important demographic differences in fairness judgments, as well as about the property assignments, do exist, and especially exist in some specific domains. And this is a result that definitely warrants future research, in particular with more diverse samples, to look more into it. Thank you very much for your time. I hope you enjoyed my presentation, and I hope you have a great day.